Okay, class, we're about to start Chapter 5, Exponents and Polynomials. Section 5.1, Adding and Subtracting Polynomials. Objective 1, understanding the vocabulary used to describe polynomials. A polynomial is a single term or the sum of two or more terms containing variables with whole number exponents. So far, we have experienced linear polynomials and one and two variables. List a few examples of other types of polynomials in one variable. Okay, we got x squared plus 3. We got y squared minus 7. We can also have x squared plus negative 15, and so on. Okay, now it says a term is composed of numbers and or variables that have been combined using multiplication, possibly including exponents. The numerical coefficient or coefficient is the constant multiple in a term. For a term with one variable, the degree is the variable's exponent. Recall that a term that consists of a single number is called a monomial. Okay, so we have the term negative 5x to the 7th power. The coefficient is negative 5 and the degree is 7. 3x, the coefficient is 3, the degree is 1. Because even when the exponent is not shown on the variable, it's assumed to be 1. A squared, the coefficient is 1, and the exponent of the variable is 2. For 12, even though we don't have a variable, 12 is still the coefficient, but the degree is 0 when there is no variable. And here the coefficient is 0, and the degree is also 0. The degree of a polynomial is the greatest degree of all the terms of the polynomial. Polynomials are often written in descending order. Variable exponents decrease from left to right. A polynomial of degree 1 is called linear. A polynomial of degree 2 is called quadratic. And a polynomial of degree 3 is called cubic. Okay, now we have to fill in the table. Now, I took the liberty of filling in parts of this table here. Okay, now we look here. We look at the variables and we find the one that has the highest degree. So this is 2. The highest degree here is 5. The highest degree here is 3. And the highest degree here is 4. Now we look to see if it's cubic, quadratic, linear, or none. So remember, if your degree is 1, it's linear. If your degree is 2, it's quadratic. And if your degree is 3, it's cubic. But all the rest will be none. So the degree here is 2, it's quadratic. I just put Q for quadratic. 5 is none. 3 is cubic. And 4 is none. Now, they want us to rewrite this in descending order. Now, there was a little problem with this where I could not write this in descending order in this graph. So what I did here, I have this other Word document up here, so I can potentially write this in descending order. So let's take a look at this first expression here. Now we want to write it in descending order, so we will put negative x squared first and then plus 3x. That would take care of this first expression here. Now, the next thing. This is a little lengthy, but we put the negative 4x to the 5th minus x to the 4th. And I'm going to run out of space here, but you could write this straight out. Plus 2x to the 3rd plus 3x minus 6. So that would take care of the second expression. The third expression is already written in descending order. And the last expression, we have to write 10x to the 4th plus 8x squared plus 6. Okay, now we have a polynomial with exactly one term is called a monomial. A polynomial with two terms is a binomial. A polynomial with three terms is trinomial. Okay, now we come to example 3. Fill in the table below. We have our expression. We have to mark this as monomial, binomial, trinomial, or not a polynomial. Now this is a trinomial because we have three terms. So we put our x for trinomial. X minus 7, that's two terms, is a binomial. And negative 3x squared is a monomial because it's one term. Now we scroll down here to these last three expressions, or these last three expressions. Now if you notice here, this denominator has the variable squared, so this exponent is really negative. In a polynomial, your exponent must be a positive integer, well, 0 and a positive integer. It cannot be a negative integer. So that's why this is not a polynomial. Now, this right here is a polynomial, but we didn't put down the quartic category here, so we have to mark this as not a polynomial. This is not a polynomial because the exponent is negative. Now we have like terms are terms with the same combination of variables with the same exponents of the variables. Only the coefficients may differ. List examples of terms that are like 9x squared. We could write x squared. We could write 2x squared. We could write negative 1/2 x squared. We can even write negative 2x squared. These are like terms to the 9x squared. List examples of terms that are unlike 9x squared. We could put 9x to the third. We could put x. We could put 1/2 x to the fourth, and so on. Now, example 4, it says add the like terms of the polynomial wherever possible. Write the result with descending powers of the variable. Now, these two terms are like terms. So we know negative 6 plus 8 is 2, and we bring down our x cubed. So this is our final answer. Now here, we look here. Now, we have x squared and x cubed. So we'll start with our x cubes. 5 minus 9 is negative 4, and we bring down our x cubed. 4x squared plus 3x squared is 7x squared. So this here is our final answer. Now we come here to C. The highest exponent we have is cubed, so we would start with that. 2p cubed, 4p cubed, and a minus p cubed. 2p cubed and 4p cubed is 6p cubed, minus p cubed will give us 5p cubed. Negative 7p squared plus 8p squared would just give us p squared. And then we'll bring down our plus 2. So we have 5p cubed plus p squared plus 2. Now, we scroll down here. It says add polynomials. To add polynomials, combine like terms. Now, first thing we always do is look inside our parentheses to see if we can combine anything. We cannot. We look for exponents on the outside, and we look to see if anything is multiplied to our parentheses. We have none of those situations. So what we do is, with our first parenthesis, we can bring that out. So we have 4x cubed minus 8x squared. Now we have plus this second parenthesis. We could bring this parenthesis out. Plus a negative 2x cubed is a negative 2x cubed, or minus 2x cubed. And then we bring down our minus 5x squared. Whenever you have a plus sign in front of a parenthesis, you just drop the parenthesis and bring it down as is. Now we combine our like terms. We have 4x cubed minus 2x cubed, which is 2x cubed. We have negative 8x squared minus 5x squared, which is a negative or a minus 13x squared. And that is it with that problem. Now we go here. We have the same situation as here. So we drop our parentheses. And since this is plus, this would be a positive 7x squared minus 2x. Now, we have no like terms for the x cubed, so we bring down our 5x cubed. No like terms. Matter of fact, there aren't any like terms here. So we'll bring these down. Well, actually, there is one set. We have this negative x and this minus 2x. Negative x minus 2x is a minus 3x. And we're done. Now we scroll down here to C. Now this is longer, but it's still the same concept. So we will have 2x cubed minus 7x squared minus 9x plus 1 plus 5x cubed minus 3x squared plus 6x minus 4. So we combine the like terms. We add 2x cubed plus 5x cubed is 7x cubed. Negative 7x squared minus 3x squared is minus 10x squared. Negative 9x plus 6x is a minus 3x. And 1 minus 4 is a minus 3. And that is our final answer. Now, we scroll down here to the next page. We want to subtract polynomials. To subtract polynomials, first distribute -1, then combine like terms. So we start this off the same as we do with the addition. We see if they have anything in common inside the parentheses. See if there's any exponents or any multiplications. So we will pull this out of the parentheses. So this would be 2x squared minus 7x. And because this minus sign is in front of the parenthesis, you could do -1 times both of these terms, or you could use this little how should I say, trick here. Whenever you have a minus sign in front of a parenthesis, all you need to do is change the sign of both of the terms. So this 4x cubed will become a minus 4x cubed. This positive 5x will become a minus 5x. So now we combine like terms. So we add negative 4x cubed plus 2x squared, and a minus 7x minus 5x will give you a minus 12x. And that's it for that problem. Now we go here to B. B is the same setup. We add 3a cubed plus 7a minus 5a squared. And then we just change the sign of everything inside this parenthesis. So we have a minus 5a cubed minus 4a squared plus 2a. Now we combine our like terms. 3a cubed minus 5a cubed is a negative 2a cubed. Negative 5a squared minus 4a squared is a minus 9a squared. And 2a and 7a is a positive 9a. Now, one thing that I neglected to say was this here. When it says distribute by -1, only thing that happens when you multiply by a -1 is that it just changed the signs of numbers. That's why I told you that when you have a minus sign in front of a parenthesis, it would just change the sign of the numbers. Now we go down here to this problem here. Same setup. We will have 6x squared minus 4x plus 8. And this minus sign will change the sign of everything inside this parenthesis. So it'll be a negative 9x squared minus x plus 2. Now we combine the like terms. 6x squared minus 9x squared is a negative 3x squared. Negative 4x minus x is a minus 5x. And 8 plus 2 is 10. And that's it for that problem. Now with this problem, number 7, we have simplify. It's just a combination of everything. So we have 5x cubed minus 3x minus 4x cubed plus 7x squared minus x plus 2x cubed minus 6x squared. Now we combine the like terms. We have 5x cubed minus 4x cubed plus 2x cubed. This will give us 3x cubed. Now we have 7x squared minus 6x squared is a positive x squared. And we have negative 3x minus x, which is a minus 4x. And that is it for that problem. Now we're about to start example 8, dealing with graphing. It says graph y equals 3x squared minus 8 by completing a table of ordered pair solutions. Now, when we substitute in negative